Parallel circuits. Parallel circuits are a much more useful tool in getting you prepared for your electricity wiring project. And so here we see just a simple bulb, and just like before we're going to add another bulb to it, but in this case, instead of breaking the circuit and making it part of one big loop, we're going to instead make a little bit of a figure eight. The wires come like this and like this. So coulombs can come from the battery and either go through this light bulb and back, or they can come to this branching point and say, I'm going to go to this bulb, come back, and run back to our battery. And so they have choice. A couple of things that immediately jump out at us is that the bulbs didn't get dim as before. And they are not dependent on each other functioning for the other to work. And so they're bright and independent. So how do we explain that? Well, we're going to go to our multimeter here and check out the voltage first. So 6 volts is what our power box is set at. And so we're going to test our first bulb right here. And I'm going to make sure that I set this on voltmeter because the other will short circuit it. And now we should find you're getting about 5.8 volts. Okay, just shy of the 6 that are available to it. And similarly at this one, 5.8, just shy of 6 volts. And so losing some energy to the wires, but our bulbs essentially get all of the energy that's available to the coulombs as they travel through our battery. So they're not sharing as they did in series circuit. Let's look at what the amperage is doing. The flow of coulombs, also known as the current. So to test, we're going to test this branch by itself and this bulb by itself on this branch, and then the total amperage. So first, the amperage of the first branch. The light should go out as you're testing this, and we need to switch over to the other side. So we've switched our dial and our leads, and now we see that 0.06 is our amperage for this bulb, the same amount that it had been by itself earlier. And if we're going to test this one, this is the branching point, and so we need to separate it from the bulb. There we go. And we're going to insert it into the meter right here. And so it's a little hard to see with all these wires going, but what we've done is just gotten in between the branch and the bulb, and we found that the amperage for this section or this branch is also 0.06. So they have equal voltage and amperage as if they had been there by themselves. Final thing to note here is the total amperage on the system. So to do that, we're going to extract our meters from here, and we're simply going to go right into the main branch itself. So we're going to slip this off. And so if we have 0.06 going through this branch and 0.06 going through this branch, what we find is that we get 0.11, almost double, going to the total. And so this main branch has to provide the amperage for each of the side branches, and so it is equal to the sum of each of the amperages in these bulbs. To sum up, parallel circuits are generally the way you want to go. Each branch gets its own full supply of energy. If something breaks in it, it doesn't affect the other bulbs. Although you notice that on the main branch, the amperage has gone down because it doesn't have to provide it for both bulbs now. Parallel circuits, it's a beautiful thing.